Right, so we're going to look at the next conic section, which is the first one that appears in your book, which is on parabolas. Now, we've already talked about parabolas in huge depth in the beginning of pre-calc and then also last year in Algebra 2. But they kind of look at it in a different way in terms of, being part of a cone that was sliced. So if you take a cone and you slice it through just one half of the cone on a diagonal there, that cross section forms a parabola. So that's what we're going to look at. And there's qualities for the parabola that are more depth, and really more depth than we're going to get into. So if you look through the notes here, they talk about this line being a directrix and then this other point being a focus. And there's a lot of neat applications of that, but again, I'm just going to give you the pieces that you're going to need for calculus. So we won't get into depth in terms of, where does that focal point have to be and where would the directrix be if the vertex was in this spot and that sort of thing. But those 2 points, the line and that point, a parabola technically is formed by all of the points that are the same distance to this focal point and the same distance to this line. And if you measure the distance to the line, it would be a perpendicular, distance there is what you would be finding. So when these two are the same, you plot a point, and that would be a point that's on the parabola. If you move up here, the distance to the focal point here, the distance to that directrix, in this direction here would be the same distance. That would be another point. And it's just all of the points that are going to be that same distance away. So like I said, they're going to go into all kinds of detail about, this line, and they give this in, axis of symmetry and directrix and all. We're just going to really deal with the vertex and then, how to graph it. So this is kind of old stuff that you did, a lot last year and the beginning of this year. Talking about the graphs of parabolas that open up or down. Those are functions. So y equals x squared is the parent graph. And then doing things like putting a coefficient out in front will make the graph either narrower or wider. If it's a negative value, it'll change the direction that the graph opens. Instead of opening upward, it would open downward. A number inside the parentheses there with the square on the outside is going to shift your graph left or right. If it's a minus, it shifts it right, and a plus, it would shift it left. So it's kind of opposite of what you would think it would be, because in the formula here, it's a minus. X minus h is the formula. And then finally, a number added or subtracted to that squared term is going to shift your graph up or down. And that's that k value that's outside. So those transformations you dealt with a whole lot. So let's just review real quick a couple problems here. So if I ask you to describe this equation here, you could tell me things like it's shifted, right 3. And when I say shifted, the whole graph, all the points are shifted to the right 3. All the points are also shifted up 4 for that plus 4 in the end. The negative 2 is going to make this open downward, or it opens down. And then the 2 is going to make it narrower. And it's all compared to that x squared, y equals x squared graph. And if you look at the second one here, it's just some more combinations here. So it's shifted left 4 and down 5. And that 1/3, since it's positive, it still opens upward. But the 1/3 is going to make it wider. So there's transformations, and that's really as involved as you need to get with those descriptions of how those graphs are going to change. But what we're going to end up looking at is parabolas that open left and right. There's something that's very new. So if you have a parabola like you did last year and the beginning of this year, vertex form, that's going to be the form that we put this in. I kind of avoid general form. I usually don't bother with vertex is negative b over 2a. You could, but we're going to end up completing the square with so many of these problems, you'll get pretty good at that. So I'm going to stick with that. So vertex form, which is really nice because by looking at the equation there, I'm just going to make this a little darker. You can tell what the vertex is. You can tell which direction the parabola is going to open. And getting a sense of what the graph's going to look like. So for this one here, we have y equals, this is x minus 3 squared plus 1. So if we look at that graph there and go through and sketch that, and just make sure I get that equation right. Yeah, that's the way it looks. So one point that we could come up with would be the vertex, and the vertex would be at +3 and +1. Then I find the easiest way to go through and graph these is just pick a couple more points. And you want to pick one point that's to the left of that vertex and one point that's to the right. And when I say a point, I mean an x value. So if this is going to open upward, and I know that because it's a positive x squared, my a value there would be 1. So I'm going to pick a number that's smaller than 3 and bigger than 3, and usually I just go one above and one below. So if I do x values of 4 and 2, if I plug those into this equation here, 4 minus 3 would be 1. 1 squared is 1, plus 1 is 2. I should get the same outcome if I went the same distance in the opposite direction because you have symmetry. So 2 minus 3 would give you -1, squared would be 1, plus 1 would give you 2. And then you just plot those 2 points, and then just connect that with a nice smooth curve there. Right, and that's all you really need to do with the graphs for parabolas. You don't have to go wild and crazy and come up with all those other values as well. If we did this in more depth, we would talk about that focal point that would happen in here and that directrix line, which would be on this side, and how those points would be the same distance to each of those. We're just going to stick with just basic graphing here. All right, so now this is the trickier part. This is the part that you haven't seen. So now if you look at graphs that are in the form of x equals y squared, the parent graph, x equals y squared, is going to be a parabola that opens either to the left or to the right. Since this is positive y squared, it's opening to the right, just like a x squared would open upward, where the positive values would be. So negative y squared is going to make this open to the left. But the same things are going to happen. If you have a coefficient for that squared term, it's going to make it wider or narrower. The shifting left and right and up and down, it's actually consistent with what you did with the other one. Y always goes with the k, so this is y minus k, and the k value shifts the graph up or down. So this 2 is going to shift your graph up 2. Plus 3 is going to shift the graph down 2. So think y minus k squared or y minus -k squared if you think of it in those terms. And a value outside now that would go with the x value there is going to shift your graph up left or right, just like it did before. So now your h value is outside of the parentheses and the k is still here with the y. So if you keep that in mind, that'll help you put the equation in that standard form there. So really, for these problems, to graph parabolas that open left or right, and this comes up a lot in calculus, instead of picking values for x and solving for y like you're used to, you're going to do the opposite. You're going to pick values for y and solve for x. So first thing you want to do is you want to isolate, get x by itself. So get rid of that 2. So I would have x equals 1/2 y squared. So the side of the equation that is more complicated is the side that has the y squared on. So they're going to be the values that we pick. So pick a nice value. A nice value to plug in here would be 0. So if I let y equal 0, y squared, 0 squared would be 0 times 1/2 would be 0. Pick another value for y. I'm going to pick 2. So if I have 2 squared, that's 4. 4 times that half is going to give me what? 2. And if I picked -2 and I squared it, that's going to give me 4 times that 1/2 out in front still gives me 2. So now I have, again, 3 points. If I started with 0, I picked a value for y that was +2. So when x is 2, y was +2. When x was 2, y was also -2. And you can see the parabola is going to open up to the right, just like it should have, because it's a positive y squared up here. It's the same idea. You want to pick values. So I start with 0. I picked a number bigger than 0 and smaller than 0, or on either side of 0 to come up with those other points there. We should probably label the vertex, I'm guessing here. 0, 0. Looks good. All right, so pick values for y and solve for x. Some people try and put these in their calculator and rearrange and think backwards and stuff. I think it's way harder than just doing it like this. Pick values for y and solve for x. So this one you can kind of think in terms of that standard form of the equation. Or like I said, I just pick some values here. So if I start with y is 0, 0 squared plus 3 is 3. If I pick 1, that's going to be 1 squared plus 3 is going to give me 4. If I pick negative 1 squared is 1, plus 3 is also 4. I'm going to start plotting those and see if I have, both the top branch and the bottom branch of the parabola. So 3, 0, 4, 1, 4, negative 1. You can see that the parabola is going to open to the right. We have both branches there. And that 3, 0 is my vertex. If you want to think of it like this, we said x minus, it was a, h minus k squared, or y minus k squared plus h. Your h value was 3. There it is. Your k value, we didn't have a number added or subtracted with that y squared, was your 0. That's your vertex. Okay, that's what it turned out to be there. So for letter D, for this one, you're not given, you have 2 y values in this one. So there's a few ways that you could go through and you could graph this one. We could put this in standard form, which we have written up here. I'm going to write this down here and then slide this. Oops, plus k plus h. No, that's not what I wanted to do. Let me clear this and try again. Here we go. All right. So if I y minus k squared plus h. There we go. So if I put this in standard form, you could still pick points. You could pick values for y and solve for x. It's going to work just fine. I'm going to try to put it in this standard form. So I want this thing to end up being factored so it looks more like that. So just like you did for the factoring when we did circles, we'll get the y terms together. Now I can't have this be a negative y squared, so I'm going to take that negative out of the parentheses. And if I take that negative out of the parentheses, this plus 4y is going to become a minus 4y. And then we could say half of 4 is 2. 2 squared is 4. I got to do something to the other side because I really just added negative 4 to the problem because of that minus out in front. So on the left-hand side, I got to put a minus 4. On this side, I can factor. We'll have y minus 2 quantity squared. And then again, if I put that, this constant term, that minus 4, back on the right-hand side, now it's in that standard form for the equation. The vertex is at hk. Remember, h is always the x value, and k is always the thing that's with the y. So my vertex for this one would be 4, 2, h and k. So that's my vertex 4, 2. And then I'm going to pick a value bigger than 2 and smaller than 2. I'm looking up here, 0 would be a nice easy number to plug in. I'd have 0 minus 0, which is 0. And if I pick a number that's bigger than 2, since I went 2 smaller, I'm going to go 2 bigger because I know I have symmetry going on. That would be 4 times 4 would be 16. And then 4 squared is 16. 16 minus 16 gives me 0. And then if you look at this, look at our equation down here, we had a negative. And then if you connect these points here, the parabola now opens to the left, which makes sense because it was a negative quantity y squared. And this vertex was at 4, 2. So you don't have to do this completing the square part and get the equation in the standard form. It made graphing it a little bit easier if you had just picked values. You just need to make sure that you pick values on both sides of that vertex. You need both the top and the bottom branch. So that makes it a little bit trickier there. All right, so this one we could kind of do the same thing too if we want to, this one's already in that standard form, so we can come up with that vertex. So the vertex for this, remember h, k, it's kind of in the opposite order of it of what you're used to. And then we can pick some values for that. I'm going to plot that vertex to start. So x is 1, y is 3. And if you look at this, this is a positive 2 out in front, so it's going to open to the right since it's a y that's squared. And then I'm going to pick a value for my y value. I'll pick something that's smaller than 3 and something that's bigger than 3. Something bigger, 4 would probably be easy to plug in there. 4 minus 3 would give me 1. 1 squared is 1. 2 times 1 would be 2, plus 1 would be 3. Then I'm going to pick a number smaller than 3, like 2. It's going to give you negative 1 squared, which is 1, times 2 plus 1 will give you 3. So 3, 4, and 3, 2. And again, you have all the points. 3 points is plenty to go through and graph a parabola, unless you don't have points on both pieces there. And then the next example, that's for the second day. So I'm going to stop here, and we'll make another quick little video for day 2.